Alright, so I am making a top-down game. The first thing I'm going to show is just the scene that I have set up. This is actually my camera test scene, since I made a camera controller for this already. I've got this directional light, and I have these two controllers, the AI controller and the player controller, and the position that they're in is actually a little bit important. So I have these visualizers so I can actually see where they are. Um, you'll see why that's important later. And then I have these two pawns. And these two pawns are basically the exact same. I have not yet made them into a prefab. However, this AI pawn has a nav mesh agent on it. We've got the camera target. Now, what this actually is this is actually a camera. So I've got the camera up here, and then I have the camera target down here. And so the reason the camera target exists is because this is a third person camera. If I want the camera to smoothly rotate around a point, I don't want to have to like move this like this over and over again. I don't want to have to do that. Instead, I just take this camera target, I put it wherever it needs to go. So if I want to target this guy right here, I put it over there. Then if I want to rotate, I just do this. And it works with Y rotation as well. However, I haven't implemented the controls for that just yet. And then I have this level. This level just is a cube right now, and it has a nav mesh agent on it. If I had a wall, the players would walk through them because the collision exists, but it isn't actually factored into how they move yet. So if I had, for instance, a ramp, they would walk through the ramp, and you'll see I'll just be able to walk on thin air as well. However, the AI won't be able to pathfind outside of this nav mesh. Anyways, the way we move is with root motion. So I've got this animation controller right here that has 3 blend trees. It's got the walking blend tree, the crouching blend tree, and this should be sprinting blend tree. And if we take a look at them, it's just very, very basic blend tree. Let me play this. And you see it uses root motion to move around. There are some hiccups here and there. I probably need to go find an animation that is not imported correctly, but that will be saved for a different time. If I hit play right now, give it a minute. Sometimes I wish there was a cancel button. You can see I can move around with root motion. If I activate crouch, now I'm using the crouching blend tree. And if I activate sprint, now I'm using the sprinting blend tree. And it all works nicely. So if we open up our scripts, I have a humanoid movement script, but that's actually empty right now. All of my logic is stuffed inside the pawn. I plan to refactor it later on and extract all of this movement stuff into a different component. I've got this run, so basically the way all of these controls simply set different values, and then they update the animator. And the animator is this right here, is the animation controller. It just tells the animation controller what parameters to use. And one of those parameters is a vector 2 for which direction it wants to be moving in. So a horizontal and a forward, as we saw in the blend spaces for the walking, running, and crouching blend spaces. It's pretty simple except for the coroutine that I have for acceleration. I don't want the character to be able to instantly accelerate up to max speed with the press of a button, because it looks kind of weird with root motion. It looks very choppy if they just like immediately blend between animations. So I've got this coroutine that whenever you try to move, it will smooth damp the value up to the max move speed, or the max input in this case. This isn't actually changing the move speed, this is just changing the input into the root motion animation on space. So yeah, and the AI controller and the player controller both call these functions. So for the AI controller, this is essentially the make decisions event that happens every frame. It's saying to run with the move input this AI controller has. That move input is calculated from the nav agent, and player controller just gets that from its on run event somewhere, on walk event. Yeah, this is a callback from the input system that I'm using right here. I have these events, and I was originally going to have controller support as well. However, I'm having some trouble syncing up some complex things with controller. I plan on implementing controller support later on though, but maybe not right now. Something's wrong. Oh, that's game soon. Okay, so let us check out this checklist. Yes, so the player does rotate to face the mouse. In fact, inside of humanoid pawn, there is a variable for the look target. Now, this is literally just the position that this pawn is looking at. On update, we basically just tell it to look at the target right here, yes. And all of this logic is just so that it smoothly looks at something. So if I open this up, you see I don't instantly like flick between. It sort of slowly goes. That's what that Quaternion logic is for, the math. And inside the player controller, the way it does that is basically, I originally had it on aim update. However, that only happens when the mouse moves. If the camera moves, it doesn't update. And so when the camera moves, obviously the position of the mouse raycast would change. But so it means I have to do this in update. So I've got this if statement block. So if we are using mouse and keyboard, it will do the raycast every single frame. And it's actually going to set the position of this player controller to the position where the mouse ray goes. And then we're going to tell the pawn to look at this position. And the AI does basically the same thing. It says to look at this position, but then always be looking forward, because right now I haven't implemented rotation logic for the AI at least. So we use the we're basically using the controllers as an empty object to store targeting information, just like transform information. So if I were to go into scene and I grab this AI controller and moved it around, it's being used as the empty object for the pawn to get targeting information for moving and whatnot. Yes. So inside of my camera controller, this is a pretty complicated, bloated camera controller, but it works very, very well. Let me show off the features that it has first. So we've got zooming, and we have, if I press middle mouse button, I can rotate the local Z. And as you see, the camera smoothly follows smoothly rotates and smoothly zooms in. And the way this is done is with a bunch of coroutines. I've got these lerp coroutines, and these are all basically the exact same thing. Over time, if the current X rotation, so this is just an example, if the current X rotation is not at the desired input X rotation that we get from the player controller, we're just going to smooth damp towards it. Yes. And I have this piece of logic here, so if we're close enough to, if we're close enough to the desired rotation, we just set the rotation as that and then break out. So, yes, there's that. And I have a whole bunch of these setters. So all you have to do to change the camera's parameters is just change a setter, and it will automatically start coroutines and end coroutines for it. So these don't actually they don't represent what the camera is currently at. These are where the camera wants to be. And so if you ever set these, they automatically inside of them they start a coroutine for lerping towards it. Yes. And I've got zoom smoothing, X rotation smoothing, Y smoothing, and I believe I had position smoothing. Position smoothing is different though. Instead of doing that in a coroutine, I do that in update. So it's literally just smooth damp towards wherever our target is. Very simple. Yes. However, one extra thing that I did, so I don't use rigid body colliders yet. That wasn't actually shown off yet. I plan on putting that in a refactor later on. So something to show off with Above and Beyond is that my character is looking this way. I'm going to press W and they still walk north. If I look in this way, I press W, they still walk north, no matter their own angle. Now if I rotate too fast, then it starts to glitch out because the rotation speed isn't fast enough to keep up. But another even more amazing thing is if I take the camera target and I rotate the camera target, say 90 degrees, if I press W, it updates to match. So we rotate and we move in the global north, in not the global north direction, but in whatever is north of the camera, or whatever is forward from the camera is north. And that's pretty amazing. And the logic for that is so simple. When I realized it, my brain exploded. So inside of this setter for the movement input, we have this function called rotate input. Now, the movement input is just a vector too. And if you need that to be rotated according to a camera and according to a pawn, all you have to do is multiply it by a quaternion. So I create a vector 3, I multiply it by these quaternions, and then I create a vector 2 with its x and z, and that will effectively take that vector 2 and rotate it around based on the camera and the player. Pretty amazing. And I have this done in the setter so that inside of update I just have to do this, and what this does, this basically just recalculates this rotation, because the pawn can rotate even if we're not changing our WASD input or changing our mouse but, and it works very well. If I walk off the edge here, you'll see I float like I said I would. And all in all, it's pretty great. My code is commented enough. I don't really need to look into here because this is a black box. I know it works, so I just say what it does. Yeah. Anyways, that is all I have to show off right now.